3 times box is equal to what? 9. Alright, you are welcome to another episode. We are starting with equations. So let me lay down some foundation for equations before we start solving questions. What is an equation? An equation is a mathematical statement with an equal symbol between two expressions that have equal values. Example, 4x plus 3 is equal to what? 11. So this is a mathematical statement, okay? The mathematical statement is that when you add 3 to the product of 4 and a number, it will give us what? 11. I take it again. The mathematical statement here is that when you add 3 to the product of a number which we don't know and 4, it should give us what? 11. So this is a mathematical statement. So it has what? The equal to sign, meaning 4x is the same as 4 times x. X is a number. So 4 times a number plus 3 should give us what? 11. Now, the equal sign doesn't just mean here comes the answer. So most often, usually, when you are writing and then you see 3x is equal to, what is the answer? No, it's not just here comes the answer, no. But it means it's the same as. Are you getting it? So it means that if we write, let's say here 3, let's say if we write here 9, then it means that, mind you, 3x is the same as what? 3 times x is equal to 9, right? So when we were in nursery, you remember, we used to do something like this. 3 times box is equal to what? 9, right? And then what will be in the box? 3. So 3 times 3, 9. So here will give us 9, here is also what? 9. So it means that whatever is on the right hand side is the same as whatever is what? At the left hand side. This is what the equal to sign means. That whatever you have here is the same thing you have over here. I hope we understand. So it's a promise of perfect balance. Are you okay? Everything on the left side has the exact same value as everything on the right side. That is what I've explained. 3 times box to give us 9. For us to satisfy this, we need to have 3 in the box. So over here, 3 times 3 is what? 9. And over here we have what? 9. So here is 9. Here is 9. I hope we are following. Great. Now let us look at types of equations. Types of equations. Okay, so I don't want to keep this long, so I'll only talk about 3 types. We have other types. So 1, let us talk about linear equations. Okay, linear equations. So an example of a linear equation is like x plus 1 is equal to 3. Now what makes this a linear equation? Now for linear equations, the variable, okay, when I say the variable, I am referring to the letter. The highest power that any of the letters will have is raised to the power 1. That is what makes this a linear equation. So there will be letters, or there will be a letter, but the highest power any of the letters will have will be raised to the power what? 1. That is what makes it what? Linear equation. The second equation I want us to look at is quadratic equation. Now for quadratic equation, we are saying that the highest power any of the letters will have will be what? 2. So let's say we have 3 is equal to let's say 9x. Are you okay? So you see that this is a letter, this also has a letter term, but the highest power, okay, this x is raised to the power 1, the hidden one we don't write, but this x is raised to the what? The power what? 2. So the highest power any of the letters here has is what? Raised to the power 2, and that is what makes this a quadratic equation. Now the third equation I want us to talk about is a cubic equation. I know, yeah, I guess. What do you think is going to be? The highest power any of the letters will be what? 3, exactly. X raised to the power what? 3, right? Plus, it can be 9x cubed, okay? Plus, let's see, 4x is equal to what? 3x squared. This power x here is raised to the power 1. This is raised to the power 2. This is raised to the power what? 3. The highest power, okay, here, when you look at the letters, okay, is s to the power x raised to the power what? 3. And because of this, it makes this equation what? A cubic equation. So these are the types of equations I want you to know, at least for now. Okay, so let us look at the parts of an equation. Okay, parts of equations. Okay, so let's say we have 6x plus, let's say 3 is equal to 8. Okay, now we call this 6 here, okay, we call it the coefficient. Okay, you see that this 6 is attached to what? X, or it is being multiplied by an x. Okay, so we call this x here the variable. The letter, we call it the variable. Are you okay? Then, and we call the sign here, okay, the plus, we call it the operator. Are you following? Great. We also call this 3. This 3 here, we call it the constant. Are you getting it? And just like you guess, we call the 8. The 8 is also what? A constant. Are you okay? So whenever you have a number attached to a letter, okay, the number is called the coefficient, okay, and then that letter is called the variable. The plus, the minus, the times, the division, they are called operators. This alone is called a constant, and this alone is also called what? A constant. Are you following? Now, the whole of the 6x, okay, the whole of this 6x here, the whole of this 6x here is called a term. Are you getting it? The whole of this 3 is also called what? A term. And the whole of this 8 is also what? A term. Are you getting it? So when you have 2 or more terms put together, then it becomes what? An expression. When you have 2 or more terms put together by the help of what? An operator or a number of operators, it becomes what? An expression. Immediately you have equal to sign in between them, then it becomes what? An equation. So if let's say we just had let's say 6x plus 3, we will say this is what? An expression. An expression. It is an expression. Are you getting it? But immediately we had the 6x plus 3 equal to 8. Because of this, it is no more an ordinary expression, but now because of the equal to sign, it is what? An equation. So these are the parts of an equation I want you to at least know for now. Great. Now, let us look at the concept of equations. I wouldn't waste a lot of time here. Now, I want you to really understand the concept of equations. Okay. Now, the concept of equations can be associated with seesaw. Are you getting it? So it can be associated with the seesaw. Then there is a bar, right? I think this side is longer, something like this, right? Then you see one human being seated here, maybe another person too seated here. Now, let me give them eyes. Some hair, right? So these are the human beings seated on the seesaw. Now, if you look at this, you realize that it is not tilted to one side. It is balanced. That is to say that this person's weight is the same as this person's weight. So, because of that, everything is what? Balanced. And that is the concept of what? Equations. The concept is that every single item here should balance all the items here. I take it again. All the items you have here, you must have similar items to make sure that this thing remains balanced throughout. That is the concept of equations. The same things here should be the same things here. So it means if let's say I have a box, 3 boxes, each weighing 3 kilogram, 3 kilogram, 3 kilogram, and let's say I have just one big box here. If we are going by what I said earlier on, then it means that we said everything here should be equal to the value of everything here. The value of everything here should be the same as what we have here. It doesn't matter we have 3 different boxes. Over here it is just one box. But over here it is 3 boxes. So with each weighing what? 3 kilogram. So the weight here will be what? 3 kilogram plus 3 kilogram, right? Plus 3 kilogram. And this pivot here is our equal to sign. Are you getting it? Great. So let's say we don't know the weight of this. So let us represent this big box here with X. So the idea is that whatever we don't know its value, whenever we have something and then we don't know its value, we will let a letter represent it. And mind you, our concept is that the value of everything here should be the same here. So 3 plus 3 plus 3 is what? 9 kilogram. So if the whole of this place is 9 kilogram, then it means that we will need what? We will need 9 kilogram at this side to ensure that this, seesaw stays in what? Equilibrium. To ensure that this seesaw what? Remains what? Balanced. It doesn't tilt to the other way or to the other side. Are you getting it? So it means that if this side is 9 kilogram, then automatically this side is also supposed to be what? 9 kilogram. I hope we are following. Great. So I want you to solve this and drop your answer in the comment section for me. So let's see. I have a basket full 5 kilogram, 5 kilogram. This is 10 kilogram. This is 2 kilogram. And then over here too, I have a basket. Okay. And then let's see, I have here 6 kilogram, 2 kilogram, and then I don't know the weight of this. I want you to find the weight of this here for me. Kindly drop your answer in the comment section for me. So thank you so much. Thank you so much. This brings us to the end of our introduction to equations. If you found value in this, kindly like, subscribe, and share with your friends so that we can all grow together. However, if you believe I could not explain something properly to your understanding, kindly leave a comment, drop a comment in the comment section, and I will gladly respond to it. Thank you so much for your time.